Labguy here. Today I'm going to give you a general report on the progress being made on the Chief. The Chief's been on the shelf for a long time. The arrival of the KOTV Monoscope Tube caused me to break it out and test the tube with it, and that was all well. That came out very good and proved the point. We were successful with the KOTV Monoscope Tube station ID card / test pattern recovery there. It could have been better video than I got. It was usable. We did get usable images from the tube, and several persistent issues with the Chief were revealed again. And though I didn't want to go down this rabbit hole, I went down the rabbit hole. There were some issues with the phase and frequency response, which I have successfully repaired on multiple occasions. Each repair revealed another issue, and so on. So we'll get into that. I will talk about that as I go through the various pieces of video I've shot over the past week. I have a lot of video in the can for this episode. And there were problems with the positioning, there was problems with the horizontal scanning, and so on and so forth. And I addressed each issue, and as I mentioned, each solution reveals yet another underlying issue, and it's classic engineering. This is not unusual at all. And as you go, you fix the grosser and grosser problems, and the remaining issues get smaller and smaller, but emotionally they become greater and greater because they're so much more annoying and so much more difficult to locate their cause and to repair them. So without further ado, let us begin looking at the various takes of video since I started this. What we're looking at here is the bottom view of the Chief, and I'm going to get in there tonight and do some work on it. And the first thing I'm going to do is to go up here to the video board, upper right, and this capacitor, this big variable capacitor, has got to go. You see how it's out on wires and mounted to the back of the unit? That is the capacitor that has fixed the video equalization issue with the video amplifier. Unfortunately, because it's out on wires like that, it's acting like an antenna, and it's attached to a high impedance node in the amplifier. It's picking up interference on the high voltage board for the monoscope tube. So noise from that switching power supply is getting into the video amplifier through that capacitor. There's a second issue with the high voltage. These capacitors right here are the coupling network for this green wire coming down from the deflection board, which feeds beam blanking in to the grid of the electron gun in the monoscope tube. Unfortunately, those two capacitors are too small for the job, and I have purchased new ones which are much bigger. These are something like 300 picofarads, and the ones that I purchased are 0.1 microfarad, 1000 volt rating capacitors. But I'll demonstrate how easy it is to get the video board out of this unit. I made everything plug in and very simple to service. It's held in by 4 nuts that are easily accessible with the nut driver. and all of the connections are made with these red connectors that you see here. The first one up here is plus and minus 12 volt power. This connector, the second one down, is all of the signals from the sync generator. This one, this 2-pin, is the video output, and this last connector is the video preamp coming down from the top of the tube enclosure. And then these two wires plug on to a pair of pins to connect this capacitor to the video amplifier. Just work the board loose and rotate him out thus. This is the back side of the board. A little busy, but not bad as these things can go. And that's the this is what I call the video output processor. The next thing I'm going to do is to remove this capacitor because it works and it doesn't work. The entire capacitor had to be insulated from the case because it's not operating at ground potential. I believe had it been grounded on one side, I would not have the noise problem that it's experiencing. So it's got to go. I didn't want that anyways. There we go. The capacitor is out. We're going to replace it with these little tiny ones that are in here. I'm going to try to mount this little guy directly into the board up against this ground plane where it'll be shielded from the noise. So that means I have to unsolder these pins and the wires on the back side and then wire this small capacitor in, and this will make it so that it picks up far less electrical noise. We'll just get started. First thing I have to do is to remove the 2-pin header, and we'll do that right now. Well, one of the pins came out. There we go. Alright, well, we've got that out. I'm going to continue to clean up the area. Now I solder one pin down, and then I like to press the part all the way in, make sure it's seated. Alright, it's soldered in, but not connected to anything because I want to check that it does not short out. I don't want it shorted to ground. There we go. Or can I get ground? I can get ground right here. I'm going to make sure this guy's not shorted to ground. Of course there's a wire getting in my way. Okay, he's not shorted to ground. He's not shorted to himself. So the capacitor is now connected, and you'll note that it's located right here, and the lead length is about as short as it can get, and that's right in here, hard as hell to see. So in high frequency electronics, lead length is everything. So it's time to put this guy back in and then hook everything up and turn it on. Alright, putting him back in, same procedure in reverse. Only with that big ugly capacitor removed, it's much easier to get in there now. Okay, all 4 nuts are back in. I tighten them up. Now we reconnect the connections. Power, sync, video output, and video input, preamp input. And that's pretty much it right there. So I've talked about this power connector for a while now that I installed. I don't know if I ever showed it. It plugs into the other side of this thing. And we'll go ahead and do that. Get the juice hooked up. Alright. The power box is down on the floor. I don't have juice turned on. There we go, AC is on. I'm going to start warming up the tube. This is KOTV's Monoscope Tube in the Chief right now, so I have to proceed very carefully so that I don't break anything. And then we'll see how the video looks here in a moment when it warms up. I've got everything connected to the oscilloscope and so on, so let's move the camera to that. Okay, let's turn on the video. Alright, there we go. If you'll note, the center circle can bloom as I turn up the beam on the tube. But that's not what we're concerned with. What we're concerned with is that white shadow to the right of that black circle. So we're going to adjust this new capacitor to minimize that effect. And there we go. Now I'm going the other extreme, and you can see the picture's gotten very, very low contrast. So we adjust until that white ghosting has just ended. And that is where the setting is nearly optimal. We will reset that with the proper 2F21 tube. But the key observation is that all the noise in the video has decreased dramatically, the switching power supply noise. So the new capacitor has fixed that. So next I'm going to show you how we change the tube in the Chief so that we can try out different tubes. So stand by for that. Alright, this is the normal operating position of the Chief. This is the top of the tube enclosure, and it's a shield in and of itself made of copper, and it shields the preamp from external interference. So the first thing we do is we remove this. Then there are 4 screws holding the preamp to the top of the tube. So we unplug the preamp cable from the base unit and we loosen the screws. I've only tightened 2 of them this time out because I've been taking this thing on and off quite a bit, and 2 screws is enough to hold it in position. And if you recall the series where I built this thing, there's a pogo pin in the bottom that makes contact with the center pin in the tube. So we just put this aside, and then very carefully we pull the tube up out of this fixture. And this is the KOTV Monoscope Tube. You can see the test pattern plate inside this tube. The contact to the test pattern is through this center electrode, and there's a side electrode that is part of an electrode called the collector, which collects secondary electrons which get knocked off. We're looking at the back side of a mica plate that has the aluminum, it's almost aluminum foil that contains the test pattern wrapped onto it. The only support that plate has is the one wire in the center, which is probably spot welded to this electrode, to this connection. So it's not possible to see the test pattern with the eye without busting the tube open. We're not going to do that. We're going to be very careful because this is a piece of history from KOTV in Tulsa, Oklahoma, and it was my great honor to test this tube for them, and we will be putting it back in one final time before I'm done. But we're going to put in the proper 2F21 test pattern tube so that we can set that capacitor, the new frequency response capacitor, exactly right, and then put this tube back and get a good picture from it. This tube is my 2F21, and you can see they've painted the entire tube black. This keeps out stray light, which can cause the electrons to be emitted and disturb the image within. It also has the second contact here, and it has the center contact here. Now, one immediate difference you'll see when I turn the unit back on is that the location, the rotation of the test pattern is apparently arbitrary in these tubes. I think the data sheet says it's not, but there is a difference. There's a 90-degree difference between a 2F21 and the 1699, which is the custom tube, as in the case of the KOTV tube. Alright, so we place our tube back in the holder, down through the deflection coil. Right here is the deflection coil, down into the socket, and we use the side electrode as the reference because I have a contact spring inside here that must connect to that, and that's what determines the rotation of that image. Okay, and that's now seated all the way in. The tube is plugged into the socket. Now we reinstall the preamp. I built it so that the interconnect cable comes out what is essentially the back side. Don't know if you can see that. And now we have to center this carefully over the tube so that the pogo pin makes contact with that central electrode. We're way off. That's typical. And I can't see in there. Huh. Try it again. Alright, that seems to be it. We tighten down our screws very carefully. Plug the preamp back in and place the shield back on the top to prevent the preamp from picking up external noise. And then we turn on the standby switch and warm up the heater in the tube. I've now set up the camera so that you can simultaneously see the monitor and the oscilloscope and the inserted video from the capture. I'll turn on the the chief and start the video capture now. And now I start to turn up the beam in the tube, and we will slowly start to see the test pattern. And as you can see, it is rotated almost 90 degrees from the other tube. So to fix that, I will rotate the deflection coil down in the unit by hand to swivel the picture around till it's right side up. A bit contrasty, isn't it? Okay, so now we will do the centering controls to center the image properly. The width control a bit, and horizontal centering, height. We want that circle nice and round, and we want him centered. And you can see in the captured image the smearing to the right side of the dark transitions. Our picture is now right side up on the monitor and is pretty square in the video capture. So the next thing I have to do is to turn the unit back up on its end and adjust that capacitor. Okay, I have tilted the unit up. I'll turn it back on, and of course by moving the unit the image has moved on the screen. Of course, that's perfectly normal. So we go back to centering, we change our width control because it will be affected. On the right side of the captured image you can see the blanking problem that I have to deal with shortly. So we won't worry about that for now. Why it shows up on its side but not when it's upright is beyond me, but there it is. We'll move the vertical centering up a little bit. And if you look closely you can see that smearing in the video, that overshoot. So we're going to adjust this little yellow capacitor and we're going to make that go away. Just like that. Well, just like that, huh? And yeah. It's very touchy, but it's there. So the frequency response is now set up, and hopefully I won't have to touch that again. We're going to break the video right here. It's getting long enough as it is. There are other issues, mainly that folded over retrace image on the right side of the picture. I chased that around for a couple of days. It is retrace related, but the retrace blanking circuit, which I rebuilt, was not the issue. I rebuilt it, I tested it, and in the next video I will show you the results of that work. And then we'll get into the actual fix for that actual problem. So, thank you for watching up to this point. Welcome all new subscribers. We're still getting a few almost every day, and the numbers continue to grow, and I want you to all know that I appreciate every one of you. Welcome and greetings to all of my current subscribers, and thank you for your loyalty. If you liked the video, be sure to give it a thumbs up. If you know somebody who likes this subject matter, be sure to let them know about the channel. It's a great place to get knowledge about old electronics like this in an area that almost no one else covers. And until next time, Labguy out.